Hello and welcome to the final IB Math Speedrun of today with me, Vince. We're just going to be finishing off the chapter on function operations, and let's jump right in. So, what else do we need to know about function operations? There's a bunch that we just need to clean up. So first of all, we have something called the identity function. This just refers to, and normally this just refers to y is equal to x, and it's a function that if we say f of g of x is equal to something, f of g of x is equal to g of x, where f is the identity function. That's it. So the identity function should leave the result of the original function unchanged if it's applied in a composite manner. Okay, the next thing we need to talk about is the inverse of a function. And the inverse of a function is, say we have a function g of x. The inverse of the function, f of x, will make it so that the output of f of g of x would be equal to x again. And we can also notate this as g to the negative 1. It's like reversing the process of g. And so g to the negative 1 of x would also equal to x. So the inverse of the function is normally obtained when you swap the domain and range, and this can be a useful trick when trying to find the inverse of a function. If the inverse, which is a relation, of course, if the inverse relation is also a function, then we say that the original function is invertible. It means that, you can invert it. Okay, so, and other things to know about inverse functions is that if there are two functions that are inverses, if we plot them graphically, they will have an axis of symmetry along the line y equals x. Since if you take any x on one of the functions and you pass it through that function, you'll get this value. What I meant is, if you take any x and pass it through one of the functions, you'll get this value, and if you pass it through again, you'll get the original x value. Yeah. That can also be useful. It's also very nice symmetrically. And only functions that are one-to-one and onto have inverse functions. If a function is many-to-one, it has an inverse relation, and we can still use that to work a function backwards, but it will not be a function. Okay? And a function is self-inverse if its inverse is, itself. And so one example of a self-inverse function would be 1 over x, because the inverse of 1 over x is simply 1 over x. And we can check this later. Well, actually, no, we can just check it right now, because if you pass in, say, f of x, where f of x is equal to 1 over x, well, we have x, f of x would be f of 1 over x, and if we pass 1 over 1 over x, this will be equal to the x again. Sorry, I think I hit that. Yeah. So it is there. And so now we can start on some questions regarding inverse functions, and we can, I'll be doing the even ones this time again, because I'm feeling even. We haven't done even questions in a while. So what we need to do is we need to find the inverse of each function if it exists, and justify your answer algebraically and confirm graphically. So the first function is y is equal to x minus 2 over 3. So the easiest way to find a function's inverse is to use the property of swapping y and x. If we swap y and x, then that means that if we put x through the original function, and through the inverse, it should output as itself again. So we have the function x equals y minus 2 over 3. And normally we want to rearrange this to get y, to get this entire thing in terms of y. So we have 3x is equal to y minus 2, and therefore y is equal to 3x plus 2. And this would be the inverse function of that. Okay. Now let's tackle another one. We have the function y is equal to 2 over x minus 3. Find the inverse function. Well, we swap these two. We have x is equal to 2 over y minus 3. And then we need to convert this a little. So we have y minus 3 is equal to 2 over x. So y is therefore equal to 2 over x plus 3, just as long as x is not equal to 3. And the only other condition is x can't be equal to 0 either. Oh, sorry, I meant x is not equal to 0. Okay. Now we're on to the final function, and that would be y is equal to x plus 1 over x minus 1. Find the inverse. Well, we have x is equal to y plus 1 over y minus 1. And so therefore x, let's multiply x by y minus 1. So xy minus x is equal to y plus 1. We bring y over to this side. X times, y times x minus 1 is equal to x plus 1. And so we simply have y is equal to x plus 1 over x minus 1. And that's it. Yeah. Okay. So, yeah, looks like all of those were correct. And now we can move on to the next questions. So the next question, or actually the final question for today, it's been pretty fast. I might do another one. Is that given that f of x is equal to x minus 1 squared, and g of x is equal to 2x plus 1, show that the composite, let me write this out. It's quite a long function, so we need to show that f to the net minus 1 compounded onto g to the minus 1 of x is equal to g compounded to f to the minus 1. Okay. So let's rewrite this in a form that I like better, which is f to the minus 1 g to the minus 1 x. And this will be, we need to prove that this is equal to g to the f of x to the minus 1. Okay. So let's first get what this is. We need to find the inverses of both functions, so let's find them up here. We know the inverse of x minus 1 squared, well, we can say that y is equal to x minus 1 squared. And if we flip x and y, we'll get the inverse. So x is equal to y minus 1 squared. Square root of x is equal to y minus 1. And y is equal to the square root of x plus 1. For g of x, well, 2x plus 1, the inverse is simply x is equal to 2 times y plus 1. X minus 1 equals 2y. Y is equal to x minus 1 over 2. So now that we have the inverses, we can solve this problem. Oh no, that's not what I meant. Okay, let's put that back. Yeah. Okay, so, well, this will be equal to f to the minus 1 of g to the minus 1, which we know is x minus 1 over 2. And so this will be equal to the square root of x minus 1 over 2 plus 1. And, well, what's this g to the f of x? And we need to find that out first, and then we can find out what's the inverse of that function. So f to the x is x minus 1 squared, and g to the x is 2x plus 1. So we know this is going to be equal to 2 times x minus 1 squared plus 1. And so we need to find the inverse of this function. So what is the inverse of this function? Well, this would be swap x and y. So x is equal to 2 times y minus 1 squared plus 1. X minus 1, sorry. Minus 1 over 2 is equal to y minus 1 squared. And so square root of x minus 1 over 2 is equal to y minus 1. So y is equal to the square root of x minus 1 over 2 plus 1. And if you compare that with what we got earlier, which is we can find up here, we can see that they're the exact same, so we prove that they are equal. Yeah, so that's all for today's speedruns. I hope you enjoyed speedruns. I hope you're following along and learning some math along the way. And I hope to see you in the next speedrun. Ta-ta for now.